All right, so let's talk about Mint. So thank you for coming. Mint, I'm super glad that, first of all, that we're having this talk at the same time as an embedded devices talk, because I don't have to go to it, because those talks kind of get on my nerves. Yes, yes, perfect. I had this written down in the notes, so this is good. It was so good that I had to write it down. Yeah, my name is Andrea. That's my username on the internet. I'm part of the Elixir core team. I've been for 3 years, I think now. I work at a company called community.com. It's a company that does things. Talk to me if you want to know more. And we are hiring. Surprise. So we're going to talk about Mint, which is an HTTP client for Elixir. It's a very different HTTP client than other clients that exist out there. I built this together with Eric from the core team. I hope he's here, because otherwise I'm going to be very offended. But yeah, if he's not here, I mean, he gets the credit anyways. And what we're going to talk about today is the story and the feature, the story how Mint came to life, the features that it has, some use cases for Mint, and some challenges that we had while implementing it, and the future plans for the library. So as I said, Mint is an HTTP client, so let's keep that in mind. The story of Mint is how Mint was born. So you know, in Erlang ships with a HTTP client called HTTPC. HTTPC works fine, but there was some discussion at some point to remove HTTPC from the Erlang distribution, so it would be packaged as a separate application, and we kind of panicked a little bit because we use HTTPC. Can you? Like, this is hand-drawn, right? Like this hand-drawn emoji. Yes, yes. Yeah, it's going to be a roller coaster, because some slides are going to be very nice, and some slides are going to haunt you for how bad they're drawn. Yes. Yes. OK, so we use HTTPC for a bunch of stuff. So Elixir needs HTTP for a bunch of stuff, like fetching packages, for example. So if HTTP was going to go away from the Erlang standard library, we needed an Elixir client. So an Elixir HTTP client that we could use, and it would probably ship with the standard library. So we got to work. This is one of the haunting slides, as you can tell. we put our hats on, and we got to work, yes. And we wanted to have this client in the standard library, so we wanted a client that was low-level enough, because we don't want to build high abstractions in our standard library, because we don't want to guess what people need. We would just want to give them the tool to build whatever they want. We wanted it to support HTTP1, because that's what we use in Hex, and we wanted it to be secure, because I mean, we want a client to be secure by default, an HTTP client to be secure by default. And this was the new client that we were building, so we also wanted it to support HTTP2, because at some point Hex might move to HTTP2, and I mean, the web is kind of moving towards HTTP2 anyway, so we wanted to have this support for HTTP2 as well. So someone, can you guess who has two thumbs and got a great idea on how to build this client? Someone else in the core team. They still have 2 thumbs, and they got a really good idea to build this client, which is to build a processless client. So basically a client that doesn't impose a process architecture. It's just a data structure that you pass around, and that's your HTTP connection, your HTTP client. So it doesn't have any processes involved. So we're going to explore how this architecture works during the talk. Yeah, so let's talk about the overview of the client and the features. As I said, it's a processless client. What you can think of Mint as a wrapper around GenTCP. So if you use GenTCP or SSL in Erlang, they provide interface with TCP and SSL, and they provide sockets. So the socket is your interface with the connection, and the socket is a data structure. It's not really a process. It's just a thing that you hold in a process and you do stuff with. And you can send data and receive data from the other end of the connection. So GenTCP and SSL, they deal with raw data, they deal with raw bytes. So Mint is basically a wrapper around that. So a Mint connection is a data structure that contains a TCP or SSL socket, but kind of knows how to speak the HTTP protocol as well. So instead of exchanging raw TCP or SSL just bytes, instead of exchanging just bytes, you exchange meaningful HTTP things. So for example, you exchange requests and responses, and it knows how to encode and decode requests and responses, so it's a little bit, it's GenTCP, but with an HTTP layer on top. This is how you start a connection, just to get familiar with the client. You have mint.http.connect. You pass in a scheme, a host, and a port, and it returns a connection. So the connection you can see here in the bottom is a data structure. It's just a struct. And that contains the socket, and it contains a bunch of state about the HTTP interaction. So especially in HTTP2, it turns out that there's a lot of state in a connection, so that's what the connection data structure holds. When you want to make a request, you just call mint.http.request, and you pass in the connection, a method, the path, headers, optionally a body, some options, and you can pass it around a bunch of stuff. And so it returns doing a request is not it's an asynchronous thing. So it's equivalent to a TCP send or an SSL send. So you're basically just sending the request to the server. You're not getting any data back. You're just doing the send operation. And as you can see, when you call mint to the HTTP request, it returns the connection and a request reference. We're going to talk about the request reference later, but it's important to notice that the connection is just a struct, right? It's an immutable data structure, so you have to rebind it and you have to keep it updated. It's like with any immutable data you have. If you have a map and you put a new value in it, you have to kind of store the new map somewhere. You have to not throw the new map away, otherwise it's immutable, so the key doesn't really go in there. And it's the same thing with the connection. When you do a request, the state of the connection will be updated, especially in HTTP2. So you have to save the new connection and keep using the new connection. Every time you do a mint operation, it's going to return a new connection that you have to keep using because it's immutable. So let's talk about responses. So how do you get a response? So Mint is a streaming client, which means it's streaming by default. It only does streaming responses. So it means that the responses are streamed back to your process instead of being synchronous. So we don't wait. When you do a request, you only send the request. You don't really get responses back until later on. That's what the request ref is. So the request ref that is returned when you do a mint.http request is a reference, which is a unique term that identifies that specific request, so that you know that when a response comes, it will contain the request, and you know that it's for that request. So it will help you identify what request a response belongs to. So again, this is just sending the request. You can send multiple requests. A connection can contain more than one request. So you can have a single connection where there are multiple requests in flight. And with HTTP, this is just like a pipeline of requests. So there's just a queue of requests that you send that are waiting for responses. And when the responses come, they come in order. In HTTP2, this is requests that are actually in parallel. We're going to look at that later a little bit. But just to say that a connection can have multiple requests in flight. And you can receive responses for different requests. So that's why you need a way to tag the response so that you can bring it back to the request, to the right request, with the request reference. And now let's talk about responses. So how do you get responses to your, let's say, main connection? So it's important to know that when you start a main connection, the process that starts it becomes we call it the controlling process, because that's what TCP and SSL call it as well in Erlang. So the controlling process is what receives the data for the connection. Mint doesn't really do any intercepting of the data. So when you get a response from the server, you will get it as a normal TCP message or SSL message containing data. That's how it works with GenTCP and SSL. You just get the data back from the server as messages, like Elixir messages, to the controlling process of the connection. And Mint doesn't intercept those, so you have to do the work of receiving those messages and passing them to Mint. So this is how it would look like. So you receive messages in your process. Now here I'm receiving any message, but you could be more specific if you wanted. But you can receive any message and just pass it down to mint.http.stream. And min.http.stream is what takes the raw data from the TCP message and turns it into meaningful HTTP responses or meaningful HTTP things. Min.http.stream can return one of three values. The first one is a really important one. It can return unknown. And this is what allows you to actually do this, where you pass any message to min.http.stream, because every TCP message is tagged with the socket that it comes from. So in our case, it's tagged kind of with the connection, the main connection that it belongs to. So if you do this, it will return unknown if the message is not directed to your connection. So you can handle it elsewhere in your code, right? So you get a message, you just try basically min.http.stream. If it's not, the message was not directed to that connection, it's just going to return unknown, and you can process it in other ways. Otherwise, it's going to return either OK connection responses or error connection reason responses. If it went well, it's going to return OK. If there's not, it's going to return error. In both cases, it's going to return a list of responses, because when you get a TCP or an SSL packet, which is a bunch of data, it can contain maybe not an entire response, or it can contain more than one. So that's why we have a list. If it contains more than one, and you get that both for OK cases and error case. In case you get data, but there's an error after, you still get some responses. These are what the responses look like. So when I said that this client is streaming, it doesn't only mean that you get the responses asynchronously, it also means that you get the responses as a stream of parts of the response. So you have, for example, the status, the headers, and then pieces of data, and those come as soon as they're received. So if I receive just the status line, and then like a little bit more bytes that don't make sense yet, I'm going to still return, Mint is still going to return a response with status. And as you can see, every response is tagged with a ref. That's a reference we've been talking about that you can use, that is returned when you do mint.http.request. And as again, you have status, that's a status code. You have headers, those are the headers. Data, you can have like pieces of data. So as soon as a piece of the body comes, you get it as a data response. And then you know that the request is finished when you get a done, or you get an error response. So a done means that the request is finished fine. An error means that it's finished and it errored somehow. But the idea is that you can, this way it's streaming by default. So if you're doing requests and you're processing the responses as they come, you can still get some value out of it, but you can also easily build synchronous requests on top of this, because you just wait for the done or the error, and you keep accumulating, for example, data. You just build the data, you have the headers, the status, and then when you get done or error, you know the request is done, and it kind of works as a synchronous mechanism as well. So let's talk about security a little bit. As we said, this was a pretty big goal of the client, was to be secure, and especially secure by default, right? That's the most important thing that we care about, because you can probably make things secure just like with a lot of effort, but we wanted it to be secure by default, so just it's secure when you use it. So let's dive into this a little bit, because I think it's pretty interesting, but we use this for testing, but it's badssl.com is a website that lets you test different kinds of terrible SSL certificates. And in this case, we're testing self-signed.badssl.com. So that serves a certificate that was self-signed, so that you either have to accept manually or that it should not be accepted. You should not push the request through, basically. And if you look at HTTPC, which is the built-in client in Erlang, and you make a request to this, as you can see, by default, it returns 200 OK. So it fails to fail, right? It should return an error, but it doesn't. It doesn't mean that HTTPC is not secure. It just means that it's not secure by default. So you can still pass in a certificate store, so a file containing a bunch of certificates for the certificate chain. You can pass it to HTTPC. You can pass a bunch of options to make this secure. So this call can get secure, but it's a lot of work, and it's very, very easy to get it wrong. But by default, it's not secure, really, because, I mean, this works, right? Hackney is what probably most people here use, including me. But Hackney is it's secure by default. So if I do a GET request to self-signed.badssl.com and I don't pass any options, I just do the request, it's going to return an error with like a TLS alert, which is what we want. So it's not like it's saying this is not safe. But it has an interesting behavior, because if I override one or more SSL options, it's going to throw away the SSL options that it has, and it's going to use yours. So if you don't pass all the options to be safe again, it's not going to be safe. So you need to, it doesn't do merging of the SSL options. So here I'm just passing version TLS v1, TLS version 1.2, which is not related to certificates really that much. And I'm passing these options, and the request is working because it's not merging that with the certificate store. It comes built in with a built-in certificate store, but it's not using it here. It's not passing the proper validation functions, and I mean, so it's not merging the SSL options, and security goes away. So it's kind of secure by default unless you use options, which is not really secure by default, I think. Mint does the SSL merging of the options. So if you do a request to selfsign.ssl.com, it's going to return an error. If you change some SSL options, it's still going to do the merging, and it still returns an error. So you have to actually want to allow this by passing the right options in order to have this request succeed. Otherwise, it's going to fail, which is the behavior that we want it to be secure by default. So even if you change some options, it's still the other options are still going to be secure. Or built for security. Mint ships with its own certificate store as well. It's called CA Store, and we have a repo up for it. So when you're adding Mint as a dependency, you want to add, CA Store as well as a dependency. If you don't add CA Store, and you don't pass a specific CA Store, it's going to complain. So it's still kind of safe by default, because it's going to say either you pass in a certificate store or you add CA Store as a dependency. And CA Store is literally a repo or an Elixir library with just one file, which is the certificate store, and we keep it updated manually, so we don't do auto updates, so that we don't risk screwing up. Every time there's an update, we just do the update and release a new version. We'll check the update, do the update, and release a new version, and you can just update that. We really, really have to thank Bram. That's his username on the internet, and he's like our security expert, because I'm really out of my depth here. Like, I'm talking like it seems like I know this stuff. I don't. I just know what Bram explained. And he's done a lot of the work to have safe SSL options by default. So it's been really nice to have someone that knows his stuff help. So we're really grateful for that. One more thing that I want to talk about is proxying, which is very boring, but with this coloring, it might be a little bit less. But it is boring. Yeah, there you go. Like, it's pretty boring when it comes gray again. But the idea is that Mint supports proxying as well. It supports a basic, kind of basic way of doing proxying, where you want to connect to like http-bin.org, and you can pass proxy options, and the proxy, it will be like another host that will act as a proxy. So it has like scheme, host, port, and options as well. And Mint uses that proxy to connect to the proxy, and then connect the proxy to the final host, to the end host. We support two ways of doing proxy. The first one, I don't know if this has a name, but I call it request proxy. So the idea is that we connect to a proxy, and then every request that we want to send to the end host has to be sent as a request to the proxy host with the full URL instead of just the path in the request line. So it's going to be like get. I say get slash on the http.org, and that's going to say get http.com/http.org slash, and it's going to forward that to the right host. So this is kind of a legacy thing. Right now, most things support tunnel proxying, which we support as well. And tunnel proxying works that in a way where you connect to the proxy, and then the proxy connects to the host, and then the proxy basically forwards all the traffic that you send to the proxy is forwarded to the host. And the connection between your client and the host is secure, is SSL, so you can even connect to the proxy via HTTP this way instead of via HTTPS, because the traffic is all encrypted. So the proxy can't really look at what you're sending to the final host. So once you send this connect in green, this connect request, all traffic is just rerouted. And this works in Mint both for HTTP1 and HTTP2, so it's pretty nice. And I mean, it works. It's pretty basic, but it works well enough. So let's talk about HTTP2 for a little bit. I'm really excited about HTTP2 because I had to write all the code for it. It's terrible. It's so tiring, and like it's, I don't know, 1,500 lines of, yes, 1,500 lines of code. for doing HTTP2. It's a lot of work, so I'm really, I'm really excited to talk about it. But I'm going to talk about it just a little bit. So the difference between HTTP2 is just like a new version of the HTTP1 protocol. The biggest difference is that instead of having a connection where you can only send requests as a pipeline, so you send a request and then you wait for a response, or you send multiple requests and you wait for responses in sequentially, you basically have what is called multiplexed streams. So in HTTP1, imagine that I'm sending 3 requests, and I'm sending one that is going to be very slow to get a response, and 2 that are going to be very fast. Since it's HTTP1, I have to send them one after the other. So I send the slow one, then I send the fast one, and the fast one. Now I have to wait for the slow one to come back, because that's the first one that has to come back, because they're in order, right? So the slow one comes back, and then 2 fast ones come back, but the 2 fast ones could have been faster, because they were faster, right? But we had to wait for the first one. So that doesn't really happen with HTTP2, because you have streams that represent requests that are in parallel. They have an ID, so you can identify which response is for what request, and they go out in parallel and they come back in parallel. So in our case, I can make the slow requests and the 2 fast requests, and I get an ID back for each, and then the fast requests are going to probably come in earlier because they have IDs, so I know that the responses are for those requests, and I can just return them to the client. So it's a little bit better organized. It's a little bit easier to do multiple requests on a single connection because you don't have to do pipelining. By the way, like a lot of HTTP1 servers don't support pipelining anyways, so you have to do 1 request and wait for 1 response, 1 request and wait for 1 response. This way you can do multiple requests on a single connection. So the browsers usually open multiple HTTP HTTP1 connections because they want to do multiple requests at the same time. This could kind of like lower that number of connections because you can do multiple requests on the same connection. Another interesting feature, and I mean, Mint supports this, like it's just a protocol, so it's not like a feature in Mint, it just supports it by default as part of the HTTP2 protocol. Let's talk about server push a little bit. So this is another feature in HTTP2, and it's a very weird feature, but it's basically the server can send the client a response for a request that the client never made. So the server can kind of say, like, here's this response, not that you asked, but here's the response because I think you're going to make this request. You were going to make this request anyways. This is often used by, again, like in the websites world where the browser makes a request for a web page and the server can push the resources like JS or CSS. It can push it already to the client even if the client hasn't requested them yet because it knows that the client is probably going to request them anyway, so you can just start sending them. Mint supports this, and they look push promise response looks like this. So you have status headers data, and this is an additional response that you can have just for HTTP2 connections, which is push promise, and it has a ref. That's a normal request reference, and it also has a promised ref. So the promised ref is the request reference for the request that you never made for the promised request. So it's going to say like this is the response for a request that you're not going to make. And the promise headers are, this is really weird to say, but they are the headers that the server for the request that the server thinks you would have made as a client. So for example, it's going to say like you will probably want to get at /app.css. So I'm just gonna, and that's what's going to be in promise headers. And that is and then you're going to get a normal response with the actual CSS and the promised ref as the reference. So, I mean, it's a bit weird, but I guess browsers make good use of this. It's not really for kind of requests, inter-services requests or stuff like that, but it's still supported. Another nice thing that HTTP2 supports is pings. So you can do a ping and you get a pong back. Or the server can do a ping and the client sends a pong back. And this is nice to like measure latency and all that kind of stuff, keep connections alive. We support ping as well, just in the mint.http2 module. So you have to do mint.http2.ping, and you get a pong response back when the pong gets back. So it's pretty straightforward. Another bunch of features that HTTP2 has and Mint supports is the back pressure. So you have, in HTTP2 by design, you have a window size so that you can only, but whenever one of the 2 peers, so either the server or the client, sends data, it's going to take that data away from a window of data that it can send, and the other peer has to refill it. So you have kind of natural back pressure because you can tell the server, wait a little bit before sending more data because I'm kind of like busy over here, and you can have built-in back pressure this way, and Mint supports this out of the box. You can cancel requests because maybe a request wasn't processed yet, and since they have IDs, you don't need to really care for the order of the requests. You have parallel requests, as we've mentioned. You have settings negotiation at runtime during the life of the connection, so you can change the settings of the connection at runtime, and Mint supports this. So for example, you want to lower the number or increase the number of parallel requests that can be open at any given time. You can do that during the life of the connection, which is really nice. I haven't really mentioned this, but Mint supports, as I said, HTTP1 and HTTP2, and it supports them kind of transparently. So there is a mint.http1 module specifically for HTTP1, if you want to force that. There's an HTTP2 module if you want to force HTTP2, and then the HTTP module is going to do protocol negotiation. So it's going to ask the server, do you support HTTP2? It does, like, there's a spec for doing this, but it's basically going to say to the server, do you support HTTP2? Server is going to say, yes, I do, and then it uses an HTTP2 connection, but you can still use mint.http to do requests and to handle responses because it's going to just use the right connection structure for HTTP1 or HTTP2. So Mint is pretty feature complete by now. So it supports streaming. We've seen streaming responses. It supports stuff like streaming requests as well, or you can send chunks of the body. It supports trailing headers. Who knows, that's a thing. I learned this, that this is a thing while building Mint. It supports chunking as well, so it's like transfer encoding and everything. It supports good error handling, especially for HTTP2, where there's a lot of logic around that, and protocol negotiation, as I said. So like, we're pretty good feature-wise. So let's talk about a bunch of use cases for Mint, because I think that's where it gets really interesting. So we've explored the client. We kind of get an idea of how the client works, but it's really nice. The use case that you can have with it, or that you can use it for, is where it gets interesting, I think. So as we've seen, we have a connection. Mint is just a connection data structure. The nice thing about the connection is that it's just a data structure, it's not a process, so you can shove it inside other processes as much as you want. And you can shove it inside any kind of process that you want. So for example, I can have my connection inside a gem server that is also doing other stuff other than keeping the connection alive and getting requests and responses. I can put it in a gen stage process, a producer or a consumer, because it's just a piece of data. I just initialize it with the state, and I keep it in the state of the gen stage process. It can be a gen state machine. It can be really anything. And since it's just a piece of data, you can have multiple connections in the same process, right? Because for connections, usually mostly I/O, so like you're going to wait around a lot if you have just one connection and only deal with that. So you can have multiple connections where you're going to handle multiple requests and multiple responses while you wait for I/O from the other connections, right? So it's nice that you can do that. A use case that I particularly like, and that I kind of like, is the first thing that I thought when we discussed the processor architecture, because it's something that I actually did at work at some point. But it's to use the HTTP Mint connection in a gen stage pipeline. So it would be really nice to use it in it's really nice to use it in consumers, because, for example, you want to kind of make requests in an evenly distributed way where you don't have idle connections, and that's your use case because you have consumers that kind of naturally, with the demand of how gen stage works, naturally do that. You can have it in producers where producing events means fetching something with HTTP requests. Then it's a really nice use case because you don't have to add an additional process, additional overhead for making the request. You can just have the HTTP connection inside the producer, and it's going to work, and you have consumers consuming those responses, basically, so it's really nice. Now let's talk about challenges that we had while building Mint. The first challenge was immutability. It's really hard, it turns out, to do a bunch of stuff when you have an immutable thing, because, for example, you can't share a Mint connection between processes. In the same way that you can't share any data between processes, you have to send it around, or you have to have a process that holds that state and other processes talk to. It's the same way with Mint. So since the connection is immutable, you really have to just deal with that and either put it in a process if you want to access it from more places, or deal with that. And it was a little bit hard to deal with a bunch of stuff because of immutability, especially proxying, because we had a really hard time, for example, coming up with a good API to do proxying to multiple hosts. So the proxying stuff that I talked about earlier kind of works like this, where you have you connect to one proxy, and you can only connect the proxy to a single host because you're really connecting to a host through a proxy. But potentially, you might want a proxy that connects to multiple hosts. You might want to use the same proxy to connect to multiple hosts and the same connection, and we kind of didn't find a good way to do that because we couldn't share any data between processes, so we had to kind of let it go. But yeah, that was definitely a challenge. Another thing that was a challenge was to make a library that is low level but usable. So it's not too low level that you have to do too much work to use it, but at the same time it's low level enough that you can do whatever you want on top of it, right? And I really like this quote when it comes to these kind of things. Easy things should be easy, hard things should be possible. If you want to take away a slide from this talk, or when you're building libraries, this one, I think. Basically, the idea is that, yeah, you should have easy things that should be done in an easy way, but hard things should still be possible, right? So in the proxying case, easy things would be doing the proxying to one host, so that should still be easy. And that is easy, right? You just pass some proxy configuration, and it works perfectly. Hard things should be possible, meaning that you should still be able to have a proxy that connects to multiple hosts, for example, and you can have that, but you have to write it yourself on top of Mint, which is doable, which is kind of the goal. So it's possible. It's not easy, but it's possible. And now let's talk about the future of Mint. So what's coming for Mint? Mint itself is pretty much done. So yes, thank you. Very spontaneous. So Mint itself is pretty much done. We are 0.4 right now, but we are just putting the finishing touches, and then we'll come out with 1.0. I think there's a lot of work to do now with adoption, so writing resources and showing people use cases of how, where Mint shines, and getting people to use Mint when they have specific use cases. And then the biggest thing to do is pooling. So we're not going to do pooling in Mint itself because it's meant to be low level, and it's meant to provide a low level interface so that people can build stuff on top of it. But we still want to have things on top of Mint that do pooling, pooling is what you usually have in an HTTP client, right? So you can send a request, and the client is going to manage a pool of connections to different hosts, and it's going to just work fine. That's probably what you want in most cases, right? And we're interested in both a single host pool and a multi-host pool. The single host pool means it's called After 8. I just started writing one, and it's a pun on Mint, which is not very funny. But the idea is that you have depending on the HTTP1 or HTTP2 protocol, you have a process. The single host pool is just a process that holds a bunch of connections to one host. So it doesn't really manage multi-host pooling, so it doesn't manage connections to multiple hosts, but at least it manages the life cycle of the connection data structure. So you have a bunch of connections in a process, and you don't have to care whether those connections are closed or they're open. It's going to do reconnection. And in HTTP2, it's a little bit nicer, I think, because you can have one connection in the process and just multiple streams, so you can do requests in parallel still, and it can do reconnection, so it can do a bunch of stuff for you, and it can take care of the actual connection life cycle for you, but without it still being pretty low level, because you still have to start a pool of connections to one host, and it's just if you want to connect to multiple hosts, you're going to have to start one pool of connections for every host, so it's still pretty low level. On the multi-host pool side, there's Pete is working on this. It's a library called Mojito, which is another pun on Mint. But the idea is that you have something that is similar to Hackney, so you just drop it in as a dependency, you start using it, and it's going to, by itself, is going to kind of start the right connections and maintain the right connections to different pools. Hopefully, in the future, it's going to be based on the single host pool that we're working on, so that we reuse as much code as possible, so we have the multi-host pool just basically open a bunch of different single-host pools. A solution that I would like to see someday is a multi-host pool based on a registry, where you have single-host pools for a bunch of domains, and then you route through the registry to the right domain, so you don't have to have a middleman process. But we're just really just thinking about this and just experimenting with this. We're not really ready to do anything. And the nice thing is that Mint itself is going to still be the foundation of all this. So it's still very useful to have that as a separate thing. And I mean, if the idea is to provide different levels of abstraction. So Mint would be the lowest level if you want to do weird stuff. Single host pool is higher level, but still pretty low level if you want to do, custom stuff, but you don't want to manage the life cycle of the connection. And then the multi-host pool is just going to do everything for you, like you're probably used to with Hackney or HTTP Poison or other clients. And then a few things that we've talked about. WebSockets, we've been asked to add WebSocket support to Mint. You're going to add it on top of Mint, so we don't really want to do that. But it kind of validates the architecture of Mint, because if you can build it on top, it means that the abstraction was right, because we don't have to change anything. Same goes for gRPC. You can build a gRPC client on top of Mint, and we don't have to change anything. HTTP3 is another thing. Just like it's having done HTTP2 and 3 is greater than 2, I believe that it's going to be harder than HTTP2 to implement. But HTTP3 right now it's pretty young. It needs support from like TLS version 1.3, I think, which is not supported in OTP yet. So I kind of say for now we don't have to do anything. But at some point we're going to have to do HTTP3 as well, because that's definitely something that belongs to Mint, right? Just a different HTTP protocol. Yeah, like and subscribe. I'm done. I think we have time for questions, probably. Yes. Yes.
Great talk.
Thank you.
I know Mint came out a little while ago, and I remember first seeing it in some newsletters and stuff and thinking like, oh, why do we need another HTTP library? Mm-hmm. I think your explanation of specifically the structure, the con structure, really makes sense. I imagine that was kind of borrowed from Plug as far as like having this con and being able to pass it around, Phoenix built on top of it, et cetera. One thing I have a question about is looking at Mint, it seems like it's kind of involved to implement when I just want to make an HTTP request as far as dealing with the streaming and having, receive callbacks and all that. Mm-hmm. Is there any plan to implement maybe a behavior on top of that so I can quickly use it without having to, write everything from scratch?
No, that's something we never talked about. It could be a solution. I think that most of the time you'll probably still want like the single host pool in those cases where it's just like a process that it works similarly to like a database connection where you just send a request and get a response. You can get an asynchronous response anyways. But I mean, that's something we could think about, sure. Like having a behavior for this. I mean, it could be built on top of Mint, so I kind of like, I don't want to do it, but it's doable. So like this is definitely something that could be done on top of it, right? So yes, definitely experimentable stuff.
I just wanted to know if you had any intentions of like mock responses, binding to ports, et cetera, as part of testing?
No. No, we don't have any. No, we didn't really do anything for testing because you can mock the connection interface if you want. You're gonna build a mock with that. It's private, but we even have a behavior for the connection if you wanted to. Like we could make that public someday so that you can just like mock the whole connection API with something like mocks, but we don't really, we haven't really done anything for testing. It's just like another HTTP client when it comes to testing. It's nice to test Mint itself because it doesn't need processes, so you can test the interaction with the server writing the test without having to wait for other processes or sending requests around, but we haven't really thought of anything to facilitate testing when you're using Mint. Sorry.
Hi. With respect to multi-host resource pool, how would you tackle rate limiting like outbound requests?
Rate limiting with outbound requests. Yeah, that's probably something you would want to handle before handling the requests off to the multi-host pool. And yeah, it's not something that I want to deal with in Mint or in the abstractions on top of Mint. But the nice thing is that if you build your own pool, which is not very hard to do on top of Mint, you can actually you can build something, for example, like a GenStage-based pool, where you have rate limiting in the GenStage pipeline, and the consumers are the things that do the request. So that's something that I'm really, really interested about, but I don't really need it. Like I know it's interesting, but I don't have time to build it, and I don't really need it. But I think it's a really interesting thing to try and build a GenStage-based pool where the connections are used to their maximum power, because like the slow ones are going to get kind of punished by GenStage because they're not going to request as many requests to HTTP requests to do, and that could kind of like pretty easily deal with rate limiting, I think, because you can build the rate limiting right in the GenStage pipeline, or you can build it in consumer if you want. So yeah, I don't think it really belongs maybe in Mint, but it's definitely doable in like on top of it. Yes.
We have time for one more question.
One more question. Make it count.
Hey, thanks for your talk. It seems like the server push stuff really only makes sense if you have caching. Is there any plans to add caching to Mint?
No, there is no plans to add caching to Mint because that's still. I mean, we had discussions about caching, but it's probably something you can build on top of Mint. And right now we're in that phase where the less stuff we build on top of Mint, the happier we are, or the less stuff we build in Mint. Sorry, the happier we are, because like if you can build stuff on top of it, it means that we did things right, because and you can build caching on top of it, right? And you can build caching on top of stuff like the single host pool, for example, if you want it, and you can build it. You can build your own pool where you have caching built in. So for now, we're not really doing anything. We're not really inspecting the requests and the responses too much, right? We're just like, the headers are just headers for us. We just forward them, or either to the server or to you, right? So we're not really. For now, we're not really planning on that. Yes, no more questions. If you want more questions, you can find me after, of course. Yes.